So here we have an example where we have two cars. One of them is going to collide with a brick wall, and the other is going to collide with a succession of soft pillowcases. Both cars will come to a standstill after their collision. Now, which car would you prefer to be in when this collision happens? Well, I think it's hopefully pretty obvious that you wouldn't want to be in the brick wall case, because this is going to seriously damage the car, and this car will have to decelerate so quickly by the wall exerting a very, very big force on the car that it's going to get horribly mangled and people will get injured inside the car. What has happened here is that the collision time is very small. It's very small. The acceleration, or rather the deceleration, on the car is very large. And so therefore the force on the car and its occupants is also very large, and that can lead to injury. Whereas in the second case, well, the time of collision is going to be quite a lot longer. It's do until it slows down. You'll feel some thuds, but you probably get away with your nice sparkly blue car being undamaged. The time of collision is very long. And as a result, the deceleration on your car is quite small. It's a gentle deceleration. So the force that must be applied onto the car to slow it down in this longer time will be lower, will be smaller. And so there will be less damage on the car, and the occupants will feel less acceleration or deceleration, and so the force on the occupants will be smaller. And so I think there's a whole happier case really for part B. So let's take this idea of the time of collision being very small, leading to lots of damage and injury, and the time of collision being very long, meaning that we get less injury and less damage. And we can design this into cars. So the longer the time of a collision, the smaller the force exerted. And this idea is used to design safety into cars. I hope that makes some sense now that we've considered those two cases. If not, go back on this video and just go through those two cases again and see if it makes sense. The front and back of a car is designed to crumple. Now this is actually designed into the car body. What we're doing is we're kind of designing the pillowcases or the pillows into the actual car, so that if the car did hit a wall, it would crumple effectively. And that means that the time of collision would be increased. So the front and back of a car is designed to crumple in order to spread out the time of a collision, and so reduce the force on you. Crumple zones is what they are called, and they do this by transforming kinetic energy, movement energy, into heat energy when it crumples. So, I hope that makes sense. If you reduce the time of a collision, then the force gets very large. But if you increase the time of the collision using crumple zones designed into the car, which crumple up like sort of soft pillows, okay, you're going to damage the car, but the occupants will be a lot happier.